So again, we're good with that page, sorry. Ratio is proportion, ratio comparison of two numbers by division, sometimes written with a colon. Proportion is an equation stating that two ratios are equal. So if I gave you two ratios, let's say like this, and I asked you, are those ratios equivalent? Yes or no? Are those ratios equivalent? There's a couple different ways we can find out. What's one way we could compare them to find out? What's one thing anybody know that? Could just reduce them both all the way and see if they're the same, right? We can't reduce 2/5 anymore, or sorry, 2/3 anymore, but we could reduce 8/12. Both of those things are divisible by 4. So that would reduce to 2/3. So these two ratios would be equal to each other. Okay? They would be equivalent. That's one way we could find out if they're equivalent or not, is just reducing both of the fractions, both getting them out of 3 and seeing if 2/3 is equivalent to 2/3. The other way we could do it is something called cross products. That's where you multiply the diagonals, you multiply the numerator and denominator of one, and you multiply the numerator and denominator of the other. And if they're equal, then their proportions are equal. So for example, it doesn't matter which one you start with. If you took 2 times 12, that's 24. And if you took 8 times 3, that's 24. Well, since 24 equals 24, that's true. These two proportions are equivalent. They're the same. Okay? So that's two different ways we can kind of look at it. We can reduce both fractions and compare them, or we can find their cross products. We can multiply the diagonals, the numerator and denominator of each, and see if they're the same. Okay? So for example, try this. If I gave you this and this, I want to know, are those two ratios proportional? Are they equivalent? Okay. Could you set those equal to each other and it be true? Well, looking at it, you could either reduce them both. Well, they both happen to be reduced already. So I know the answer is probably going to be no. If I want to really double check it, I can check their cross products. Take 5 times 11, that's 55. Take 9 times 7, that's 63. Well, those are not equal, so I would say no, these two ratios are not proportional. Okay? Those are not equivalent. So that's just comparing ratios to find out if they're proportional. Now, how do we solve proportions if we have a variable in one of them? And we're going to get to why proportions and ratios are important in just a second, but let's say we had a problem like this. Actually, I'm going to change this here a second. So let's say I wanted to solve for x here. So this is just solving an equation, but it happens to be a proportion, a specific type equation. It's two ratios that are equal to each other. And I want to solve for x. I want to know what can I put in for x that would make this true. That would make this proportion true. Anybody know how we go about solving this? Yeah.
I know what the answer is, but I don't.
One way we can do it is we can just get rid of the fractions on both sides, right? Remember we talked about last class in solving equations? If we get rid of the fractions, it makes things a lot easier. So to get rid of division by 5, you would do what to both sides? Multiply. That would go away, which means I multiply that to both sides. But let's say also I could get rid of that division by 3, and I could multiply by 3 to both sides. That would cancel, multiply by 3 here. That would leave me with 3x equals 45, right? Because 9 times 5 and 3 times x. And that looks a lot easier to solve than what I did up here. But all I really did was I cross-multiplied, right? We've probably heard that term before. I multiplied the diagonals of each. If I take 3 times x, or x times 3, that's 3x. And if I take 5 times 9, that's 45. And when you cross-multiply, you can set those two things equal to each other. Right. Cross-multiplying is just multiplying both sides by the denominator, but we can do it all in one step there. So then to solve this equation, I'd obviously have to do what? Yeah, divide by 3, right? Because that's 3 times x. Divide by 3, divide by 3. 45 divided by 3, x equals 15. That's how I would solve this proportion, cross-multiply. Right? All I did was I multiplied both sides by 5 and then multiplied both sides by 3, got rid of the fractions, got rid of the denominator. Okay. All right, let's have you try this one. Let's compare answers here. Solve for x in that proportion. Or what can x be for those two ratios to be equal? So what we're doing here is we're going to get rid of this division by x, right? We're going to multiply both sides by x, so that's going to make that 15x. And we're going to get rid of this division by 10, so we're going to multiply both sides by 10, that's going to make that 90. But that's the same thing as if we just cross-multiplied it. It doesn't matter which one you do first. If you did 15 times x first, that's fine. 9 times 10 is 90. And 15 times x is 15x. So then we would just divide both sides by 15 there. And I would get x equals 4. Yeah, sorry, I don't know why I wrote 4. It should be 6, right? So I'm sorry, 6. That 90 divided by 15 should be 6. What's here is if you had something like this. So let's say now they just happen to put 2 terms down here in the bottom. Okay. We can solve this the exact same way. We can get rid of the division by 3 on both sides by multiplying by 3. And we could get rid of the division by x plus 2 by multiplying both sides by x plus 2. That's the same thing as cross-multiplying. So if you cross-multiply this direction, let's say we did that direction first. Remember, this is 6 times this whole thing. Right? So I kind of treat it like that's in parentheses. So what's going to be when I multiply these two things together? 6x. Yep. Plus 12, right? Because I have to take 6 times all of that. So 6x plus 12, that's going to be equal to, if I cross multiply the other direction, and 3 times 6 is 18. Now I can solve this equation for x. I can subtract the 12 from both sides. That goes away. 6x equals 6, and divide both sides by 6, and x equals 1. Which that makes sense, right? If I plugged in 1 here, this would be 6 over 3, just like this was 6 over 3. Okay. But I got that by cross-multiplying, or getting rid of the denominators. Any questions with solving proportions? We feel pretty good about that? Let's say I gave you this scenario. There are 3 girls for every 4 guys in the class. Write the ratio of girls to guys. Okay? So ratio is just a fraction. It's just a comparison of 2 numbers, right? And since it says the ratio of girls to guys, okay, what number is going to be in my numerator, 3 or 4? 3, right? Because it says girls to guys. So the ratio here would be 3 over 4. Okay. If I said guys to girls, it would have been what? 4 over 3, right? So the order does matter here. Okay, that's the ratio of girls to guys in this class. For every 3 girls, there are 4 guys in the class, right? Let's say then instead, I said write the ratio of girls to students in the class. So now it's no longer, but this is the only information I give you. For every 3 girls, there's 4 guys. I want the ratio of girls to students. Okay. So I still know my numerator is going to be 3 because I know there's 3 girls. But instead of 4, instead of guys, I want the number of students. How would I find that? Any takers? Well, if you just simplified it, if there were 3 girls and 4 guys in the class, how many total students would there be? 3 plus 4? 7, right? That makes sense? If there were just 3 guys and 4 girls in the class, for every 3 girls, if I wrote girls to students, it would be 3 to 7. That makes sense? Okay. Now if I said, what if I said write the ratio of boys to students? You would say it's what? 4 to 7, right? Boys to students. Okay. With me, does that make sense how we find that? Okay. So now, let me give you a new scenario. I'm just going to give you the ratio. The ratio of girls to boys is 2 to 3. If there are 10 girls, how many boys are there? So, now I told you what the ratio is. It's 2 to 3. So that means for every 2 girls, there's 3 boys. So what is there more of in this class, girls or boys? There's boys, more boys, right? For every 2 girls, there's 3 boys. But now I told you, okay, there's 10 total girls. I want to know how many boys there are. This is where proportions would come in, okay? I want to know the ratio of girls to boys. So it says the ratio of girls to boys is 2 to 3, right? Of girls to boys. That's equivalent to there are 10 total girls. So I'm going to put that across from girls in my proportion. I went girls to boys here. I need to go girls to boys here. And since I'm trying to find the number of boys in the class, that's my unknown, that's my variable. Okay? So I would cross multiply here. So we would solve this just like we said before. We'd multiply the diagonals. 2 times x is 2x. Set that equal to 3 times 10, which is 30. I would then solve that by dividing both sides by 2. That means x is 15, and x stood for my number of boys. So there are 15 boys. Okay. What if I asked you how many students are there in the class then?
25.
Yeah, 25, right? There's 10 girls already. There's 15 boys now. There's 25 students in the class. Okay? So that's how we can use a proportion to find something missing. I gave you the ratio, I gave you how many girls there were, you found the missing part for the number of boys. Okay, so similar situation. Let's say the ratio of girls to boys is still 2 to 3, but instead, I tell you, there are 50 students. I'm going to change it to 60 actually. There are 60 students. Find the number of girls. So we changed it a little bit now. Okay. The ratio of girls to boys is still 2 to 3, so every 2 girls there's 3 boys. There's 60 total students. And I just want to know the number of girls. So I'm going to use proportion again. It told me again the proportion was 2 to 3. That's girls to boys. So if this is girls to boys, I need to make this girls to boys. But the problem is I don't know either how many girls there are or how many boys there are. Right? So I can't make this girls to boys and make this girls to boys because I don't know any of that information here. All I know is there are 60 students. So instead, I should write my proportion as girls to students. Right? Since I'm trying to find the number of girls, I can write my proportion of girls to students. So I know there are 2 girls to every 3 boys, so that means there must be 2 girls to every how many students? Yeah, good. 5, right? Because there would be 5 students here. There would be 5 students there. So since I went girls to students there, now I could go girls, which is unknown, to students here. If this was girls to students, this had to be girls to students. Cross multiply here, 2 times 60, it's going to give me 120, and 5 times x, it's going to give me 5x. I divide both sides by 5 here. We're going to be left with x equals 24. So that means there are 24 girls in the class. How many boys would there be? Yeah, there'd be 36, right? If there's 60 total, 24 boys, subtract that from 60, there would be 36. So that one, even though they didn't give me the number of, they didn't give me a ratio of students, I just made it. They just gave me the ratio of girls to boys. I made it a ratio of girls to students. Okay. So let's see what we can do here. The ratio of boys to students is 2 to 7. So if I want to just write that ratio out, that's 2 to 7. Again, that was boys to students. There are 10 girls, so girls isn't in this ratio at all. So that's not going to help me at all there. Okay? Find the number of boys. So instead of writing boys to students, I should write a ratio of boys to girls. That would be more useful. So if it's 2 to 7, what would be my ratio of boys to girls? 2 to 5, right? Because if there were 7 total students, that means if 2 were boys, 5 were girls, right? So I went 2 to 5 here. So if I went boys to girls here, then I want to know how many boys are there for every 10 girls, right? So I went boys to girls, boys to girls. Cross multiply. That's 20. That's 5x. Divide both sides by 5. There would be 4 boys. Does that make sense? The most common type of ratio problems you see is like miles per gallon and gasoline and stuff, right? So like, for example, if you had, if you drove 300 miles on 10 gallons of gas, how many miles could you drive on 25 gallons? Let's say you had this situation. So you drove 300 miles on 10 gallons of gas. That means if you had 25 gallons of gas, how long could you go? Okay. Or you can write a ratio. Let's say of miles to gallons, right? So if you drove 300 miles on 10 gallons using the same rate or using the same ratio, I want to know how many miles, so X, could you go on 25 gallons? Right? I went miles to gallons here, so I had to go miles to gallons here. You could have did it the other way. If you wanted to go gallons to miles, you could have, and gallons to miles. A mile to gallon just came first. So I would cross multiply here. 25 times 300, 7,500. 10 times x, 10x. Divide both sides by 10. So that would be 750 miles, would be what x equals. Right. Which makes sense. It should have been a lot more. It should have been over double more, because I had over double the gas, right? Really, I had 2.5 times the gas, so this was 2.5 times the miles. Okay. And that's ratios and proportions, what we need to know right now.